Hello. So thank you for watching my lecture video. So this is the video for actual exam P1. So here we're talking about some sample problems. So for this one, we just check the sample problems from problem 1 to problem 10. Okay. Okay. So for this problem, uh, we want to split all by parts with three factors. Like some people watch this, some people watch this. So here we have three factors. Uh, so we use Venn diagram. So let's say like here. So we just use this Venn diagram. Okay, and other side. So we just split all people. So based on this three factor. So suppose we put this is G gymnastic and B baseball and A soccer. So for such a problem, the key point is we should start from this one. Three overlap. Watch all of them. So this is 8%. Okay, this is 8%. Then this G and Ace is 10%. So G and Ace is this part. Right? So this part is 10%. So here we have 8%, so we know there's 2%. 2, right? So here 12 is B and Ace 12. So we know this is 4. Right? And this is like G and B is 14. So we know this is 6. And so OS is 19. So OS is 19. So we already have like 2A4. We have 14. So here's 5. So this is not. This is baseball 29. So here we have already 18. So we here 11, right? So for G, total is 28. So we have here, we have 16. So 28, 16, we have 12, right? 12. Yeah, so here 28. Okay, so then so we can find the other side. So let's say watch those so we want to find and watch none of them, so means out of this three circle. So we find totally here is let's say here we have 10, here we have 10, 20, okay, and 11, 12, and 5. So totally is 48. So outside is 52. So for this problem, we say visit the doctor's office. Result two things: need lab work or refer to specialist. So some people need LB, some people no need LB, right? So for LB, we have needed or not needed. And for this, refer to specialist. So we say refer to specialist. Also has two cases. You need refer to specialist or no need to refer to specialist. So here we have two factors, A or B, or A and A bar, B or B bar, right? So we can use Venn diagram, or we can use this table to separate those all people or get those information. So totally, so here we have 100 people, 100% support. Okay. So this is result needs label, no, this is 35. So 35 is here. Okay. And among those, so this is among those 30% refer to specialist. 30% refer to specialist. So this is 30%. 30% for this. For specialist, and 40 require, so 40 we put 40 here, so we just check 40 for label work. Okay, so then we can fill out the table. So okay, this is so this is should be 60, this should be 70, like because the totally like totally is 100. Okay. Okay, so this is 60, this is 35, then here should be 25, right? So we can fill out this table 25, and this is the 5, because this plus this is 30, and here this is 35. So we fill out the table so we can answer the question. So what is the question? Questions find the probability or percentage. So they visited to result both label, and so both is this. So 5%. Okay. So here we also have like two factors A and B. So we just put this as A. So A bar. For A, we have two cases, A or not A, right? So B or B bar, okay? Okay, so totally, by now we just put 1, okay? Okay, so let's say, so this is probability for A or B is 0.7. So where is A or B? So here's A, for this is A, there's 2 cells A, then there's B, so there's 3 cells put together the A or B. So A or B is 0.7, so we know this should be 0.3, right? And this one, so A or B bar. B prime just B bar. A or B bar, so where is A or B bar? So A, that's A. And B bar, this. So this 3 is 0.9. So this means this one is 0.1. Okay. So we find this is 0.4 and here 0.6. So this is, we say, so for APA is 0.6. Okay, so here this is, we have 2, so in here we have 4 red ball and 6 blue, and here we have 16 red one and unknown number of blue, so we put X blue one. Okay, so from here pick one, from here pick one. So the probability is both balls are the same color. So same color can be both of them are red or both of them are blue. So there's probabilities like there's probability for red and blue, both of them are blue, right? So this is probability 0.44. So let's check out what is this probability. So this red. So from here pick one, red one is 4/10, right? And then from here, pick one, the letter 1 is 16 over 16 plus x. So plus, so both of them blue one. So blue one is 6 over 10. Then here, this x, blue one is x over 16 plus x. So this equal 0.44. So we can solve for x. So at first, maybe we just put them together. So let's say this is like 10 times 16 plus x. So 4 times 16 plus 6x so equal 44. So now let's solve this equation. So for this equation, it seems easy, but here I wanted to show you like we don't want to do we want to do this quickly, so maybe we don't need it. We can simplify at the last step. So here 0.44 multiplied 10 is just 4.4. 4.4, so multiply 16 plus, so 4.4 times x, right? So put x here, so this is 1, I'm sorry, okay. 1.6x equal, so we can take 16 other side, so 16 times 4.4 minus 4, 0.4. Okay, so we can find like cancel 1.6, we get x equal 4. Okay, so here we wanted to separate so many people into parts. So here we have 3 factors like young or old, like there's age. We separate them by age, right? So age, or male or female, like gender, and married or single, so marriage. So we have 3 factors. So we use this Venn diagram. Okay, so we use Venn diagram. Okay, so let's say, so okay, so we can use this. Let's say, I have no space to put. Okay, so suppose this is like age, young or old, and here, and like okay, and here is male or female, gender, male or female, and here marriage. Okay, so we just put those numbers into here. Let's say of those okay, so 3,000 are young. Let's see. Okay, so for age, so we have some problem. Like we say like this part, maybe we just check this is for this age. So yes, so this age we have 2 parts like young or old. So maybe you can put this here means young. So outside means old. So here gender, like we say this part means male, outside means female. So here for this, the inside means married, outside is not, outside is single. So maybe we just use this. Okay. Okay. So now we wanted to put Okay. So here we say we need to put the overlap first. So what is overlap? So let's say 600 a young married male. So this is 600. Okay, this is 600. Okay. Then we just go back, right? Then just go back. So check this overlap, most overlap first. Then we just go back. So let's say okay, like this number 1400. Those people are young, married, means this young married. So this is 14. So we know this is 800 put it to here. Okay, and this number, so married male. Okay, married male is thus, right? So we put this number is 310, so minus 600, so equal 24, right? So here 2410. Okay. So then this number, so 1320 is young male, young and male thus. So 600, so here should have 720. Okay, so just like that, then go back. Okay, okay, then let's say totally married is 7,000. So married, so far we have how many? So we have like 800, 400, and 2014. Okay, so so far we have thus. Okay, so married 7,000 married. So we here we have, let's say 9 3 3, right? This minus this. Yeah, okay, we have so many, and then fill out this. Okay, so we can find this question like, okay, how many are young female? So what is young female? Which part is young female single? Meaning young. So young is that part. Female. So here's males or females not male. Yeah. And single. So married. So just this part. We want to find the number of this part. Okay. Okay. So for this problem, also quite the same. We need to separate all people by parts. So here are how many factors? We want to check 3 factors, 2 factors. Okay. So totally we have so many people. Okay. So who died? So among them, some people died from heart disease. So some people died from other disease. So here heart disease or not heart disease. So we can put heart disease or not heart disease, right? Okay, and so for some people died, some patients, their parents also suffer heart disease. So some people's parents suffer heart disease. Some people parents do not suffer disease, right? So here we also there's a fact parents have heart disease or parents do not have heart disease, right? So we know. So here we have this two factors. Okay. So now we can easily to totally separate those 937 people into parts. Not split. So let's see. Okay. Okay. So let's say so many people die from heart disease. So heart disease, this is 210. Okay, the 210 part to this number here. And 312 of those people, so 312 of those people's parents have suffered disease. So parents, we put 312 here. Okay. And of this 312, of those 312, 1 or 2 died from heart disease. So we put 1 or 2 here. So like 1 or 2 cause of heart disease. Then here is we can put this number, right? Then 210, 210, yeah, 210, 210. Those people not heart disease. Let's say 210. So here's 312. So 312 people. Those 312 people, their parents had heart disease. So they are also there. The kids died from heart disease, and the kids died from other disease. Okay, so now we can fill out the table. Let's say like here, this is 7. Let's say 2 7, and here like we can fill out the table, right? So let's check what we want to find. We want to determine the probability. But at the first, let's say, probability that people selected from this disease died of cause-related heart disease. Giving that means we just check those people. Giving that neither of his parents suffer from heart disease. So we just check those people. Okay, so giving that those people, the parents no heart disease for those people. Okay, so for those people, so denominator is this. So we want to find how many die from heart disease. So we want to find this number. So let's see here. So we can find this equal 108. Right? So the probability just this. Okay. Okay. So for problem 8 or 7 is also those problems are quite a confusing, difficult problem because too much information. So we should be patient. Okay. So let's check. Okay. So for those people who have only an auto policy, will renew, such a chance is 40% will renew. Okay, and for those people, so those people, 60% will renew. And for those people who have both, so much percent will renew. So we split people into 3 parts. Okay, we split these 3 parts. Like some people have both, some people have only this auto insurance policy, some have only home owner insurance policy. Okay. Okay. So now let's see. Okay. So how many have those auto insurance policy? This is 65%. For those people, like here, like for those people, for those people, 65%, and 50% have source, and 15 have both. So for all people, we just split, let's say, into 3 parts. Like let's say, so this those 2 policies can have overlap. So we say like here, okay, like this. Okay, so this is for auto insurance, auto, and here's for home. So we know both is 15%, and we know auto is 65% totally. So this is overlap is 15. So here is 50, right? And here is 35. Because this is the home insurance is 50%. So we find this add them up is 100%. So this means that all people have some insurance. Yeah. So we just check those people. So we'll renew. So we can see like those 50 people. We can regard we have 100 people. So for those 50 people, how many will renew? So multiply the probability for renew. So for those people, 40% will renew, right? So multiply 40%. So plus those 15 people, so 80% will renew. And those 35 people, how many will renew? For those only home insurance, they have 60% will renew. Okay. So this is a percentage for renew for all people, right? So this is also really typical example, like we split all people into parts. So those people like 20% will renew. Those people 40% people will renew. And then totally, what percentage people will renew? Okay. Okay. So for this problem 8, let's see. So for those enjoy, 22% will need both of them. So here we have two therapies, physical, this one, and this one, right? Okay, so we have 2 factors. We just put this as like, we put this as T, like a physical, so let's say T or the C. Okay. So for those patients, you need to check T or C, right? So we have two factors, so we can use this, or maybe C or T, or maybe C, or maybe both, or maybe not, right? None of them, right? Okay. So here we have two facts. So then we can put those informations. So let's say 12% visit neither of them. So outside 12%. Okay. So both. So here's 22%. Okay. 22 here. Okay. So let's say the probability that visit C exceed by thus, then visit this T. So this means that C is more than this T percentage by 14%. So we say so if we put X here, so this should be X plus 14, right? 14% more. Okay. Okay, so now we want to find this X, and then we can find everything. So let's say, so by now we can easily find this X, because the total percentage is 1, right? So we can find 12, totally there's 12 plus X plus 22 plus X plus 14 equal 100. So we can find X. Okay. So find X, then what is the question? Determine probability that the learning choose member will visit this. So we just need to find this probability for T, or just find X plus 22. Okay. So we need to find what is X. Yeah, so we need to solve this equation. So let's see. So here 2X equal, so 100 minus what, so add them up. So here is 12. So here just a little bit of calculation. I'm sorry. Okay. So what is this number? But anyways, such a problem become easy, right? You can find this. Okay. So for problem 9, it also we want to separate all people by parts. So at the first we say all customers insure at least one car. So but some people insured one car, some people insured more than one car. So for number of cars, we have two cases, like 1 or larger than 1. At least 2, right? So here's the number of cars. So the other one is for type of car. Some car is sports car, some car not a sports car. So we can put a sports car, some not a sports car, right? Okay, so we can split all by there's 2 factors. Okay, so suppose we're talking about percentage, so I put 100 here, totally 100. Okay, so now let's say, so we put this information, 70% insure more than one car. So here's 70. So then this is 30. Okay, and 20% insured a sports car. So here's 20, and here's 80. Okay. And of those customers who insure more than one car, So for those people, so for those people, 70 people, right? For those customer, for those people, 15% of them insure sports car. So this multiply 15%, I think equal 10.5. So 10.5 insure sports car. So here 10.5. Okay. So now we can fill out this table. Okay, we can fill out this table. So let's see here 9.5 because it's 20. So and here is 30. So here is 20.5, right? And we can find this. So what is the question? We want to find the part, which part insured exact one car, and that car is not sports car. So just this one, right? One car, not a sports car, 20.5. Okay. So for this problem, or this one and the previous one part is the same. We for car, we like some people insured one car, some people more than one car, right? So we have this two parts. And so for car, some car is sports car, some car not a sports car. Okay. And we put so about suppose totally 100. So we just put those information. So 64% insured more than one car. So here 64, so then here is 36. Okay, and 20% sports car. 20% here, so 80% not sports car. Okay, so just check this. Of those insured more than one car, 15% insured sports car. So just 15% of those people. 64 multiply 15%. So equal what? So just do this calculation. Okay, so this problem part is the same, right? Yeah, same as before. So let's see here, just okay, so this just equal 9.6. Let's see. Yeah, 9.6. So so here 9.6 here. Okay, so then here is 9.4. Yep, 10.4. Okay, make it 20. And what we want to find is probability which sale that insured exact one car, and that car is not sports car. So here, so just equal 36 minus 10.4. So this equal 25.6. So do we have this answer? Yeah, like about 26. Okay. Okay, so let's stop here. So we will continue